12.1 was the basic probability. Addition rule, multiplication rule. Now we're going to look at another way of looking at a population. And what this is taking a sample, putting together a normal curve based on that sample, and then making judgments about the population. What's the probability of this happening based on that sample? We're going to use something called the normal curve. So this probably might be an introduction for you for the normal curve you might never have talked to before. So that we're going to start off just by explaining a little bit what the normal curve is. The main point is how can you find probability using the normal curve, but first we have to talk about what the normal curve is first. And we use a normal distribution. A distribution is how things are spread out. So like I said, we're going to be taking a sample, and based off that sample, we're going to be looking at where things fall. We're going to kind of relate that sample back to the population. That's how we're going to have our questions then, is what would happen in the population. Now, what I mean by how things fall, if we would put together what's called a histogram, this shows you how things are falling. In this sample here, this example here, it has most things falling right around the center, and as you get farther away from that center, less items are happening. These are frequencies. So you can see, okay, for this interval here, it shows up that's about 40 times. This is just above 40 times. These smaller ones are showing up maybe 8 times. This is about 10 times. Okay, so you can see how high the bar goes is how high it's going to happen, or how often it happens. And this is what I mean by how things are distributed, okay? From close to the center, far away from the center. And we're not going to get into skewed to the left, skewed to the right. We're going to focus on the normal distribution, okay? So from here on out, assume every probability, every population I give you, every sample I give you is normally distributed. Okay? Usually there's going to have to be tests done to prove that they're distributed before you can start finding the probability. For this class, I'm going to tell you now, everything we're going to talk about, consider it normal. Okay? Normal distribution. Now, to be normal, it must be symmetric and also called the bell shape. Now, what that means by bell shape is if you would trace the density curve, and the density curve is something that just kind of goes outside the histogram and gives you an idea of how it's shaped. Okay? Now it's called a bell shape because it kind of flares out at the end, those tails, like a bell does. Okay? And when it talks about symmetric, meaning that once you're at the center, it's going to be equal on the left and right hand side. Okay? Now this curve I just drew represents the entire sample that we had there. Okay? And if something represents the entire sample, it represents 100%. So based off that sample, we're going to talk about the population. Okay? And we're going to use this curve that represents the sample to make judgments on the population. And again, it represents 100% that we're looking at. Now, the shape of that curve, we're going to base it off of two things. We're going to base it off of the average of the sample and the standard deviation of the sample. Okay? The average is always going to be our center. Okay? So if we take the sample, we have X bar as our center. Now, if we're not be talking about the population, that would be the mu symbol for the population. So the X bar represents the sample, mu represents the population, and the standard deviation, that's going to be what judges how big or the shape of our normal curve. The standard deviation is how far value is from the mean, and it measures, again, how things are going to be spread out. A small standard deviation is very, very close to the average. A large standard deviation spreads things off to the right and the left, but it is going equally to the right and the left. So a large standard deviation, or let's just base off a small standard deviation first. We have our center average. If we have a small standard deviation and the sample standard deviation is going to be S, that means that our normal density curve is going to be tall and skinny. Now, if we had a larger standard deviation, okay, so the green is on be our large, that means things aren't as close to the center. Things are spread out more. And that means that the curve's on it go up faster. It won't go up quite as high, and then come back down. Now, no matter which shape we're looking at here, the blue or the green, both represent 100%. The shapes are just different. That 100% is just spread out differently. Okay? So that's going to be what determines the size of or the shape of our normal curve. Okay? And find our standard deviation. This is the formula. And you can see the standard deviation. We have the square root, the summation of x minus the mean squared divided by n. It's taking into account how far every value is from the average. So if we subtract the average from each one of our points or data points, it's taking that in consideration and it's averaging them all together and finding out how far away are all those points. Okay, so that's what the standard deviation, that's how you would calculate it by hand, which really is not the nicest or quickest thing to do. You'll do it more if you take other probability classes. I'm going to go over one now. If we were to do this on the calculator, and the first thing you would have to do is, we did this before, entering that list. I would put that into enter into L1. Okay, so if you enter that list into L1, and then we're going to use the one variable stat. You hit stat, go over to calculate, and it should be the first one, should be one variable stat. Okay. And that will find us our average and our standard deviation. It gives you a lot of information, but for this section we're going to focus on the average, which is our x bar, and standard deviation is on the SX. S is the sample standard deviation, and it just has an X there telling you that it's the standard deviation of that list that we're looking at. Okay, so that is our average standard deviation. Okay, and if you would plug this in to make sure, just want to double check, your average for this one would be 12.6 and 1.647 for our standard deviation. All right, so that's using the calculator. And you need that average and standard deviation to now use what we call the 6895.9.7 rule, also called the empirical rule. And what this does, it breaks up our 100% under the curve. And you can see here, it's going to be broken up. This is standardized, where 0, our average for a standardized scale is 0, and we're counting by standard deviations. 1 standard deviation, 2 standard deviation, 3 standard deviations, and going to the left is the same thing. 1, 2, 3 standard deviations. It's a normal number line. You're adding to the right, you're subtracting to the left. And each section here, again, it's symmetric, it's the same on both sides. Each section is going to be representing how far away you are from the average. That section represents the percentage of that population. Okay? So within 1 standard deviation from 0 to 1 is 34%. 0 to -1 is 34%. And if you can add up those averages, that's going to give you the percentages. Now, the way we get our 6895.9.7 rule is judging off of within how many standard deviations. Within 1, as abbreviated as SD standard deviation, within 1 standard deviation, the mean is 68%. Well, 1 standard deviation, -1 to 1, 34 and 34 adds up to 68%. 2 standard deviation is 95%. So here's our -2, here's our +2. So that represents all 4 of those sections. 13.5, 34, 34, 13.5. Add all those up and you get 95%. And 3 standard deviations, -3 and 3. If you add them up again, 2.35, 13.5, 34, 34, 13.5, 2.35. If you would add all those up, that would give us 99.7. The 2 tails is what's left over. 0.15 and 0.15, putting them together gives us the 0.3 that would add up to 100%. Okay? So this is where the rule comes from. Now, what we're going to do here, those percentages won't change. Those are found, proven from those sections, and it's calculus that's doing this. It's finding the area under that curve. Okay? That's how we get those percentages. These values down here are what's going to change depending on your situation. These are standardized right now, 0 in the center, but we're going to have a situation where it's going to tell you what the average is, and tell you what the standard deviation is. And from there, then you're going to be able to construct the normal curve and label the normal curve and then answer questions from it. Right? So that's the introduction to the normal curve. The next video is I'll show you examples of the problems that you're going to do.